Hello and welcome to lecture 17. So, today we're going to talk about a lot of skills, techniques, tools you should use in the project. And this is perhaps a bit of a jump from the content-wise we had previously. And I'm going to explain why we're doing this in a second, but based on the schedule. Um, as you're aware, this coming Monday, next lecture, is a holiday. The following two lectures, we'll be using this time slot to have, during lecture time, meetings discuss your project proposal. We'll be giving you feedback and we'll be discussing it. So as a result, after today, the next time we have a proper lecture won't be for some time. The good news is actually lecture will be a guest lecture. It should be fantastic. But uh, this material I wanted to make sure we covered before we actually start doing the project. So we're going to cover a variety of things, and these are good things to do in the project. So remember in the project, you're not only doing like a larger design, you get a chance to really kind of dig into it. And the homeworks and labs, they try really hard to like pre-digest things for you. So you're only kind of focusing on a certain skill or a certain concept. I give you a lot of scaffolding code. I also like well define the problem. I'd say try to. And for the project, you're the one defining the problem. You're the one making the skeleton code and actually filling it in, right? And so you're gonna be doing a lot of things in the project. And so it's also worth appreciating some of these skills to help you kind of navigate that space. A lot of this overlaps with software if you've done a lot of software work, but of course a little bit of a hardware spin to it. Cool. So pause for a second and think. Let's say you're doing your project and there's some functionality you want to have add to it, and you realize, oh wait, there's already a chill generator 4 down line I can use. So what would you hope that generator looks like? What is the ideal code that you could get access to? Number one, hope it does the right thing. Hope it's correct, right? That's the most important thing. And it's not just about getting the right answer. It needs the right answer every time. Perhaps with the parameterized generator, you want to tell you right away the parameters you've given it are infeasible. Like it should tell you right away, no, you asked for these parameters. That's not okay. You don't want to silently fail and give you code, and that code's actually not going to work. Additionally, in addition to it being correct, you also care that you are convinced it's correct. It's not just a matter of it actually being correct, but somehow you also get that confidence conveyed to you, right? So number one, obviously correctness. Number two, if you try to work someone else's code, right, you care a lot about how easy it is to work with and understand. Perhaps is it documented? If you're looking at the code, can the code be read and understood? Can you modify if needed? Is it well structured? Efficiency, for some people, often they think it's a higher priority, but trust me, you're touching other people's codes. Efficiency, as important as it is, it's actually still farther down the list, right? And the reason why is because who cares if it's efficient if it's incorrect? Who cares if it's efficient if it's too hard to work with? These first two are absolutely required or essential for you even consider using someone else's code, right? And so efficiency does matter. You won't have not too much room to improve, but it doesn't need to be perfectly optimized, right? And so the theme of this lecture as well as this course is that writing code, the first time you write it, it's basically impossible to get all these things nailed the first time, right? You can't have it be perfectly correct, perfectly well understood, and super efficient on the first draft, right? As you said, all quarter, close the loop, get something working, keep revising, keep improving. And so that's the whole point. So in that process of, continuous improvement, agile development, how are you to keep improving and making it better? So we're going to cover some of those tools and techniques today. Cool. Okay. So more concretely, what tools we're talking about? Things like continuous integration, i.e. testing, things like code management, documentation, and actually a brief aside on open sourcing, which I hope you will consider doing for your projects, but technically not required. Okay, so continuous integration. Turns out when you're doing tons of work, perhaps in the project when you have you and your partner both working in the same code base, you're going to be trying to add some feature. You're going to be trying to fix something. In the process of doing that, it's not just possible, but actually almost guaranteed that you are going to introduce bugs you not intend, right? You're working on one functionality, changing one thing. You're going to break something else somewhere else, right? And so that happens a lot. You have a lot of development going on. Bugs find their way into your project. And the issue is these bugs could have always been there, or maybe you introduced it recently. But the point is, it's there, right? And so how do we help with that? Well, in this course, I keep saying, make tools do the work. In this case, the tools are your tests. So you have tests, hopefully, or you should. And thus, use those tests and run them a lot, right? So you can imagine, maybe when you're developing locally, it's a pain in the butt to run more than one test. You don't want to wait too long. But while you're thinking and looking at code, in the background, wouldn't it be great if some other computers run those tests for you, right? You have more tests, maybe it takes an hour to run them all. You don't want to wait for that, but fine, let the computer do that in the background. Automatically is the key word, right? And that's what continuous integration is, right? So continuous integration is automating the process of executing tests. There's different ways of setting it up. But that's kind of the key idea, right? Sometimes people refer to this as CI for short, right? And so how much you do this? Well, a common model is perhaps on your Git repository, you have it run a test every time there's a pull or a push request, no, a pull or whatever, a pull request, a commit. You can trigger it manually, do it nightly. These are all common. But the point is, you keep running a test a lot, not requiring human intervention, but actually doing it automatically. Hopefully, you'll recognize bugs sooner and be able to fix it sooner, right? And that's the whole point, right? And so, beyond actually catching bugs and seeing it sooner, there's some really nice benefits worth thinking about. When it comes to you as a customer of code looking around, seeing CI in a project adds a lot of confidence, right? You find a random Git repo, it doesn't even have a README and like no testing, you're like, You find one with a good README and CI that's currently running and the CI status is it's passing rather than it's broken. That's really encouraging. So making it publicly visible really helps. Additionally, having good CI setup makes it easy for people to actually send you contributions, right? If you have your repo set up and someone sends you a pull request, you're going to be wondering, okay, well, maybe they added the feature they said they did, but does it break anything else? And so what do? You're probably going to find yourself taking down their pull request and running a bunch of tests on it. Gee, that seems really repetitive. We should have computers do that. And there's CI, right? CI can do that for you. It'll run all your tests on the pull request. That way you know right away, oh, wait, this person had a pull request. It didn't pass the test. You can tell them, hey, you didn't pass the test. Reopen the pull request when you pass all the tests, right? Additionally, sometimes people actually want to use your CI or your tests in ways you don't even expect. For example, maybe your one code base is another code base you depend on. They want to make some big changes, but they care about you as a customer. They want to keep you happy. So they're going to change their code. And they want to see if that breaks your code. But you having tests available, they can check that. There's really a lot of benefits happening. So there's really good kind of have tests out there and trying things out. Questions and comments on CI? Yes. Oh, question. So when we say CI, does it do formatting? That's been a real strong push in the last couple of years. It's like the surprisingly exciting people about doing formatting. That's sometimes not part of CI, but yeah. So code formatting, automatic code formatting, or should not even say automatic, forced code formatting. Yeah, so it's always been possible, right? So from Git from the beginning, it's had, they call it like a pull hook, or basically every time you do something, you can trigger an action. And so yeah, now people have this notion of, launching code formatters automatically. I'm kind of the older class, older style people, which, if you believe in a certain code formatting methodology, you do that before you commit. But people don't seem to trust that. And so that's why they have this kind of notion of always doing it automatically. And that's the kind of new trend recently. Other questions, comments? Cool. Okay. So let's take this to the CI. You need three things. Number one, you need tests, which even if you don't have CI, you need to have tests. And actually, in some ways, almost is better in this course than perhaps in the pure software course, because as you've seen with Chisel so far, if you don't have a test, your Chisel design is kind of not going to do anything. You turn it into Verilog, but then you need to do something with the Verilog, right? It's not really a thing until you actually test it. So CI really lets you get the most benefit every test, right? Sometimes you have tests, especially if you have a really good test, it might take a long time to run. There's a lot of tests. With CI, you don't need to worry about how long that takes. It runs in the background. You can set up the right interval to make sense, but that's the point. Sometimes people say, oh, well, I have tests, but I don't really trust them. Somebody can definitely get by the test that's actually buggy. That means your tests aren't good enough, right? If you think something that's not correct and you buy your test, that means you aren't testing enough things, right? Nobody's tests are ever perfect, but if something passing your test does not increase your confidence in that code, that suggests you don't have confidence in your test. You should get better, what they call test coverage, in other words, test more things. With regards to automation, you don't need to invent all this, right? It all exists. So, maybe a long time ago, do set your own scripts, trigger stuff. No. Much simpler, especially in the cloud era. You can use things in the cloud, often integrated directly into things like GitHub. And it makes it really, really easy. We'll show an example of that in a few seconds, a few minutes actually. And so yeah, that's not the hard part these days. Is the automation? Yeah, use another framework. It's easy. Just got a few YAML files and you're done. Um, in terms of what does it take to actually run these? Once again, you need a place to run it. Uh, you could have a server. You can even run on your own laptop. But once again, run it in the cloud if you can. And the good news is, actually, with GitHub these days, if you have a public repo, you can use GitHub Actions, and the free tier is pretty good. Okay, so yeah, before I go to this next slide, I'm gonna go ahead and skip ahead to let's look at CI in practice. So here you are in the main Chisel repo. So as I said before, you advertise you have continuous integration and it's passing. Now, historically, these icons would be links to take you to the actual thing. Unfortunately, not the case anymore. Takes you to the picture, doesn't help you very much. But I happen to know where it is. It's under Actions, of course. So you go see here what's going on. At this particular moment, there's actually multiple CI workflows actually lively running around. So these yellow things are in progress. 11 minutes. Yeah, these things don't take. They aren't that quick, right? But that's okay. It's running on some cloud stuff on GitHub. And so what kind of stuff are they doing? You may notice how for a given, it seems like the same names appearing over and over and over again. And the reason why it's being checked in multiple ways, and there's also a variety of agents in this particular Git repo that are helping you. So in the spirit of automation, there's actually some things, such as a bot, that's actually launching additional pull requests on your behalf. But ignoring the bot pull requests, we still see some of these things, so go take a look at what's going on. That's a simple one, it's probably too simple. Let's go to a more proper test. It actually does something, not just trivial checking labels. Okay, we don't care about labels, that's too simple. Oh, okay, we're not gonna do SRM anymore. All right, here we go, add format strings. Oh my gosh, check labels. I swear there's some real CI jobs in here, not just checking labels. Oh my gosh. I was checking this before I came to lecture. This is what I get for trying to do it live. Why don't I go digging in the left and actually go through the CI flow? So they actually have multiple flows. Why is this integration is listed twice? I don't understand. But here's a more classic flow. So you can see that these flows can actually get pretty complicated, where it's not just like one simple little task. It can, actually try multiple different things. There can be dependence graphs. In this case, it's trying out a lot of different combinations of versions to make sure they all compile together, and that kind of stuff. And each one of these things, actually, here we're actually looking at what it did. These are the various run flows and outputs along the way. This is all just for GitHub Actions. This is all, set on public repo, free, can set it up. What does it take to set up? There should be inside the .github directory. We can see that. So for example, under the workflows, because it's such a complicated stuff, there's a lot more here. So Chisel's, a big project with a lot of people. But you can imagine doing a much simpler thing for your case, where basically you kind of just got to tell it, give it a name, maybe some details about what you're working on, the system image you want to use for this continuous integration image, and then what actually to run, right? So depending on how your thing's set up, you got to, pull stuff off, that kind of stuff. Like I said, this is a very complicated example, but it gives you a flavor for that. So what kind of tests would you put inside CI? Basically any test you have in general. And so you may hear a lot of these names kind of tossed out there. In your project, you may not have every single one of these, you may only have some of these, but it's worth kind of just briefly covering them all just to make sure you cover all of our bases. So first off, unit tests. Imagine like, a test a single module. Those are easiest to write. They're also really important to write, and then they're helpful because oftentimes you're debugging something, and you're trying to debug a massive chisel design with a test that tests the entire thing integrated. It's actually really hard to debug it. So having unit tests let you hone in on units not matching functionality is actually really, really crucial. These are most important. Integration tests are probably the one you're likely to write because I need to make sure the whole thing works. But trust me, unit tests are important. Integration tests, of course, testing multiple things together, perhaps even the entire design. There's some other tests you may not have heard names that I can mention right now. So for example, regression testing is making sure things that previously worked still work. So for example, Maybe your code base has support for different versions in our package, and you want to make sure you still support the versions of that package. You can add that for regression testing or make sure you didn't break anything. Sometimes you hear the term smoke tests. These are a really small set of tests that are supposed to run really fast, but check the most important functionality. If something fails smoke test, you probably want to kill it early. So for example, maybe you'll do a smoke test first. If it doesn't pass the smoke test, you don't give it the 4-hour allocation on your server because that's going to be wasted time, for example. Other times, maybe you make sure you don't blow up the design, right? Someone's changing the code and they make a change in their stuff, and all of a sudden your code is half as fast, right? Or your design is twice as big. You want to know about that as soon as possible. So performance testing helps you find that. And so they keep saying over and again, make tools do the work. You want the servers running tests rather than humans debugging and running tests themselves, right? So yes, make the tests, use automation, actually have those tests run a lot. And yeah, CI should, not just can, it should run more than the tests you run normally. Perhaps when you're developing locally, you have like the test kits working on right now, maybe you run a bigger test, but CI can test a lot more stuff. Not just check one version, check all versions of all of your dependency versions and make sure it all mesh together well and that kind of stuff. Let CI go to town, right? And you don't have to always run the same set of tests every time, right? There's different types of tests. If I go back to the chisel world, if I go back to the actions, you may notice there's like different types of tests. Some are more like formatting. There should be a nightly in here somewhere. So maybe only run it once a day, that kind of stuff. So depending on when things are run, you may choose when to run certain things. For the project, I actually recommend trying to set the most basic CI, right? You're going to have tests, and because there's even just two of you in the project, having the notion that when you start pushing to the repo, that it's going to run all the tests to make sure you're all agreed, that's really helpful. Cool. Questions, comments? Yes. Yes, yeah, good question. So performance tests, that seems like it'd be hard to set up. Absolutely. So for software, uh, now all of a sudden you care a lot about how you're running because normally if you're on a cloud and instance is slow because it's potential on the machine, you don't care because eventually it completes. If you're trying to do performance testing for a software program, oftentimes you will have a designated benchmarking machine, so that way you know it's the same hardware in the same conditions. So oftentimes, many of these tests you may run in the cloud. Perhaps performance testing for software you run on hardware you own yourself, maybe only daily or weekly to make sure it has control conditions, so it's actually able to compare numbers. And you want to know, okay, that changed my code so much it slowed down by 10%. So you have big projects, we'll kind of keep changing stuff. You watch performance of your overall program vary over time, and you want to make sure it doesn't skyrocket on somebody. Because when it does skyrocket and you find out like a week later and you got to figure out what thing caused it, it's a huge pain. That's for software. Now for hardware, in order to get PPA, of course, you need to push this through a flow, right? Some sort of flow that you get numbers out of it for power, performance, and area. That's not super easy to do in a cloud instance in an hour. So depending on how you set things up, in the spirit of this agile hard development discourse, I'm strongly encouraging a highly automated flow. So it would be good to have a flow that is largely automated for physical design. Now, obviously, it doesn't mean physical design itself is perfectly automated. It just means you have enough of a physical design flow that you can push stuff through and make sure it doesn't break. And so, yeah, this can be much more complicated. This one is another example of one you probably may run in-house because you want to perhaps keep the technology for that thing you're pushing through stuff, or perhaps the very special CAD tools you have local. But yeah, if people talk about this kind of testing, maybe having like a weekly, tape in, they call it, basically pushing through the flow locally to kind of see how you're doing and make sure you didn't have a big regression. It's good to be aware of. Because yeah, occasionally what happens is someone's doing something simple, especially like in a processor, and they have a bug, and they see the bug functionally. They go in, they fix the bug, and by fixing the bug, they need to use one more signal, do a mux somewhere to check something to make a certain thing happen. Unbeknownst to them, they made a new critical path, right? You want to know that soon, right? You want to know that. And so waiting until a month later and you're like, where's my critical path? That's not what you want to be. You want to be, within a week, you want to know, oh yeah, I know that change you may fix functionality, but now you got to figure out the critical path and fix that little detail. So some of the critical path is extremely important, right? Usually people, when they blow up area by a factor of 2, they'll know it. But critical paths, sometimes you add like a wire that, it's not obvious in writing code that this wire is going to delay or go over a long way or something, and that causes that problem. Great question. Other questions? Okay. Cool. So That was for testing. Now for code management. In this course, hopefully I've got you drink some of the Kool-Aid of all the Git required for the assignments. Using version control isn't remotely negotiable in the modern era. There's plenty of alternatives to Git that are popular. In this course, we're in Git, but no, Git isn't the only thing you're allowed to use. But you got the version control, right? Without version control, it's really, 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 really hard to do any kind of reasonable version management. Um, I have been using Git for many years, and so even though I don't know all the Git commands perfectly, I still can't imagine working without it. And one of the things I think is underappreciated is sometimes when you're working on something, it's really helpful to keep looking at the diff right now, even when you're not committing. Just remind yourself, okay, what have I changed the last time I've done something? And really think about your commits as a way to kind of tell a story. Okay, well, I made these changes and thus it, has a certain response. Kind of make sure you do a good job of that stuff. I think the bigger question is what should go into a Git repository or Git repo? Um, Interestingly, besides the code, there's a lot of things you put in there. One thing people may not be fully familiar with, and I'll mention briefly, is something called a Git submodule, meaning it's possible in Git to include another Git repo inside of a Git, inside your repo. It's actually, of course, including a pointer to that repo, but it does remember which commit you're on. So it's really helpful that we can pull in the main repo and you pull in the submodules at those repos, and then you're all set up. I've been in projects that have gone both ways. They've had a bunch of submodules. The alternative is something called a mono repo. Some people even jokingly called a mondo repo because it's really big. Having two repos, sometimes things can get out of sync. And the idea of having a mono repo is that way they're kind of literally the same code repo, so that way they can keep more in sync. Like all things in the world, I think both extremes are too crazy. You should find some middle ground. And for me, the middle ground is keep things in the same repo as long as you can. However, there are times when you really want to have things that are independent or independently usable. Then perhaps you start separating them in separate repos. And so what would I use a Git submodule for? If you have an external dependence that's not versioned, when that dependence eventually does become versioned, pulling that in as a version dependence, and that is having proper releases, is going to be a lot better for you, rather than having a Git commit as the thing you're tracking with. Some more advice for Git. Git makes it very easy to have branches. I recommend having only a few long-lived Git branches. Having tons of branches is actually kind of hard to work with. I remember in grad school being really excited about Git when I first, was getting good at it, and like, oh, every time had a different code variant, I had a different branch. And if in a year I had like 200 branches in the same repo, that was really a pain in the butt, right? Don't do that. So yes, is there a question? Oh, good question. So forks versus branches. So forks is when you're doing something for a few reasons. Number one, maybe based on the way your organization is set up, you need to fork something in order to have ability to modify it before you can do a pull request. Other times you're forking it because you're not the original creator and you want to have your own copy of it. So that's kind of like a more heavyweight thing some of the time. But the branches, I recommend it's okay to have them be short-lived. Like you're gonna try a feature out, and then when you're done, either you merge it or you don't. The problem is when you have a branch, sometimes you had this idea, you did the development, and it didn't quite work, and then you don't want to get rid of the branch because why get rid of it? But even though you didn't merge a feature, you wrote the code, you're like, oh, I'll hang on to it. And then, a year goes by, that branch is still clogging up your Git. And even though branches are cheap, a year later, that code's almost impossible to merge back in now because the code repo's changed so much. Is that another question? Sorry, what? Oh, forgive me for not knowing the terminology for this. Um, what I can point you to is let's go back to this repo for a second. Keep rooting around inside Chisel. Chisel has a bunch of branches. But what's interesting is you see how many of them are actually active, right? So what do they have going on? Of course, main. Yeah, that makes sense. But what's interesting is for something like this, which is a very carefully versioned piece of software, main is not all stuff happens, right? So actually they have a notion of what the 6 version sequence is, what the 5 version sequence is. Remember earlier I showed you there was that bot actually pulling stuff across. So depending on certain code changes, they'll make a code change on one branch and it'll question of which ones they send it to. This one, of course, is not even the code. It's actually the web page. But you can see some of these are actually, actively being developed feature changes, right? Trying to think if I can decipher these. SVSim, better, error, no, later. So So SVSim is something in development in the Chisel sequence libraries to better support a backend for running executions. That was in the older version of Chisel, and then they did the massive jump to Chisel 5, Chisel 6 that kind of took out all that code base. And so now this is them recreating that in a much more disciplined way. So perhaps this is suggesting that if you don't unveil it, you're going to be handling a lot more gracefully. This one actually looked at before the lecture, not the particular branch, but the pull request associated with it. This reminds you this is an actively developed project. There's a particular case where when you have a shift right, the question is what's the right behavior if you have a shift right amount greater number of bits there? Is that 0 bits wide as the result? Is it 1 bit wide? The results of that should be specified by the Fertile spec. Somebody found a corner case that the result did not match the Fertile spec, and that's led to a larger conversation about what should the right behavior be. And so this is ongoing debate on that front. But you can see, of course, that there's, of course, a lot of old branches, if we keep scrolling down. And the key point is when we start, even here, these are still defined as active because they're within the last 3 months. But, it's already hundreds, even thousands of commits behind, right? But if I go to actual stale branches, which these are old enough that, you might even find my name on some of these. 5,000 commits behind, right? This is not getting merged, right? At this point, this is, here for historical accuracy, right? So like I said, when it comes to branches, you'd be surprised if you are a little bit more parsimonious, even though it costs you nothing in Git, if you're a little more parsimonious, a little more careful with them, it works out better in the long run. Because if you have these other branches, like I said, they become a point where they can't be merged back in. So this comes kind of this stale thing. You're archiving code basically, and it's when you archive code only in a branch and not in the main repository, people can't find it or something. So we're all pack rats, but no, spring clean. Does it spark joy? No, let it go. Cool. And then of course also pull requests, which you can go back to this repo. This is of course the way people might not manage code. It's this massive code base with a lot of developers. If I go back to here, you can see how many contributors there are. There's quite a few, right? 131 contributors. So yeah, they all can't just push to the main branch whenever they want. So you do pull requests, right? As you see for given pull request, oh look, this one seems to have failed CI. Yeah, So that's why this is red X. Maybe you shouldn't merge this one, right? Still a work in progress because guess what? It's failing CI. So you see, it's actually, making a pull request at the start of something. In this case, they have a template for questions you should ask for a pull request. And actually, you may wonder, well, how did you make sure your code is good, or how did you do a code review? This is kind of reminding you things you do, right? Did you add Scala doc? Did you document what you're doing? Is there a test case? Do you not have any debug printfs in there, right? These are the kind of things they're making sure are not in the code or you're checking for, right? So you can see that, and then it goes through this. There's people giving feedback, that kind of stuff. There's even some people giving some feedback and reviewing. We'll talk about code reviews more in a second. But the short answer is, pull requests are a great way to kind of manage this stuff. Cool. Other questions? Okay, actually by second I mean now. So code reviews. Show of hands, who's had a code review as part of maybe industry or summer internship? A couple. How about maybe in a research group? Okay, how about in a class? Okay, so maybe in aggregate, half of you raise your hands at least once, which is great. That's way better in my experience, personally. So I think code reviews are awesome. So they're a good way to make you a better programmer and make your code better, right? So the way I describe it is that, a lot of times, especially in courses where we have these very tight deadlines and, once the homework is done, move on to the next homework right away. Basically, everything you're doing is kind of like a rough draft. You get the thing to pass the test, and then boom, as soon as you pass the test, next thing, right? But it turns out, real code lives a long time, right? Hopefully. And so you should think about actually going and cleaning it up, right? And so when you go and try and clean the code up, you can definitely think of some things yourself. You know what, I should do this differently. I know this is bad. I can make this better. But at some point, you're going to find that you don't know what would actually change or what would make it more clear. It's good to get feedback. And so compare your experience writing homework assignments to perhaps trying to write text that's good, right? Now, maybe not every piece of text you write is this good, but imagine you're trying to write maybe an essay, or perhaps for those of you in grad school, remember you spent all the time on your personal statement to get into grad school, right? Getting people to read that. You didn't just write that once, one night, and be done, right? You wrote it, you revised it, you rewrote it, got feedback, revised it, etc. And so the rough draft's only the beginning, right? Once your content complete, it's like the first like 15%, right? There's a lot of work in revising, iterating, improving, especially for readability and clarity, right? And so this is a human involved task. Who knows? Perhaps with LLMs, we have a machine involved task soon. But as of today, it's still largely human done. Um, so what should you do in code reviews? Well, uh, the main goal is to make sure you improve the code. Now, a lot of organizations have a checklist like we just saw, right? Where this is the beginning of a review checklist to make sure even for they didn't want to look at a pull request if you let's you make sure you satisfy some criteria because otherwise you're wasting somebody's time. But there's often a lot of rigidity to them, but there's also room for you to have some flexibility and kind of learn from it, right? And so what's helpful about humans looking at code, you can have code that is perfectly functional and actually perfectly correct, but can still be improved, right? And that sometimes there's places where these code can be improved that really only humans can spot. And so you'll find that both by reading others' codes and having other people read your code, you'll get better understanding what is and is not possible in language, how to make things structured better. Remember, right, when you have code, it's read far more often than it's written. And so thinking about the reading and actually changing the code to make it easier to read is really important. You see me in this course occasionally show you different code variants and then say, this one's better in some metrics, but I think this one's easier to read. Have these conversations, right, with the code. And so why do code reviews? Well, like I said, number one, helps you get better as a coder yourself. But the code itself has been reviewed, hopefully is much better shape, or at least consistent with the policies of the organization you're doing the code reviews for. But there's also a little bit of, other factors here as well. People sometimes, they're less embarrassed with computers, right? So, hey, if you write code that works but isn't pretty, but no one ever sees it, you might pull a fast one. But now if you have to talk to a coworker, your classmate, and have your name associated with that code, you might take a bit of pride in it. You might have a little bit, oh, I don't want to see this, right? I want to. So yes, shaming works, right? Making sure people have, some pride and make their code look good. And like I said, the process of talking about, discussing, makes you way better, right? So even in my own research group, I have, the occasional code review, intentionally in the group setting, not so much embarrass the student, but because that way everyone can see what factors we're talking about, right? And so having more viewpoints can really help. So I really recommend code reviews. You're going to do a code review assignment next week. It's part of why I wanted to get this lecture moved up. I'll be posting details on that tomorrow, but basically, yes, you're going to be code reviewing one of your classmates' homework assignments. And then even here, I wanted to kind of briefly highlight that one of the nice things about GitHub having all stuff integrated is that you actually can do the reviews inside here too. So actually I'm going to go find a closed pull request so we can see something that actually was completed. We want one that's not done by a bot. Okay, this one looks like it's not been done by a bot. So in this case, we're pulling up and we can see, yeah, there's some comments here, right? Oh, wait, this is public versus not public, right? And they're having a conversation about that. As an example, right? And so yes, it makes it easy to kind of with the tools here to have the conversation directly attached to the code, and not just attached to the code, but attached to the differences in the code. You can imagine that if you did this another method, perhaps you just send somebody like a long email, you keep saying, oh yes, in this file, colon, this line number, in this file, colon, this line number, kind of annoying. Take advantage of these tools where it's all integrated for you. It makes it a lot easier. Cool. Questions about code reviews? Okay, let's move on. Oh, sorry. What is the code review process? Typically, someone has some code they're trying to get merged into or the code. Depending on organization, that's either mandated sometimes. Like some repositories, you literally cannot have your code added to the main branch list. It's actually approved by an approver. The reviewer will give you some feedback. And like I said, when they give you feedback, doesn't mean you made a mistake. Doesn't mean it was wrong. It's just they're helping you make it better, right? Take that suggestion in a positive light. Instead, you're using the software we just showed you to kind of annotate stuff kind of clearly. Perhaps if they tell you to change certain things, you need to actually make those changes, and then you submit another round of review. So it may take multiple rounds of review. And then once the a submitter once the approver is satisfied, they approve it, and then your code's accepted. And so even for a GitHub repo, this is one thing, but like Of course, other places we all depend on, things like Linux has a much more rigorous review process, but similar thing, right? You go for review, they give you feedback, you make changes, you iterate. And so, like I said, this is a whole agile thing in a nutshell. It's really hard to get things right the absolute first time, but embrace the process of revising and getting better. Cool. Questions? Okay. How does Linux do CI or automated regression testing? That's why I'm repeating this for recording. That is a great question. I do not know the answer to that. I do know that for a long time, I don't know if it's still the case, the way to actually trigger a code review was to send. Yeah, exactly. But well, so they definitely have tests, right? But it's not a pretty Travis CI kind of test, right? Um, I mean, it's constantly changing. It's a massive code base, right? Um, so there's always something else being added into it. But yeah, like I said, you do want to have tests. Writing tests for an OS isn't always obvious or clear, but yes, that's a thing. Or if you want, what was the one I saw the other day? There was a Rust-based microkernel I saw the other day that had like a lot of cool infrastructure. I saw. No, it was like Redux or something with an R. Anyways, it was not Redleaf. It had like an X in there gratuitously, but maybe it's a better one. But anyways, um, the point is yes, having some sort of review process helps. Independent of interpersonal dynamics, I think it's still a really good process and it helped you. Like I said, that's what we're doing in this course. I'm going to tell you right now the protocol is I'm going to have you do a code review on your colleague's homework assignment that's already been submitted, so you didn't notice it's coming, which is intentional. Uh, and so to kind of outlay the entire process, so you're going to code review a classmate's homework assignment. And because the homework assignment you did, you've also done the exact same code. So you have some notion what it's supposed to be doing. And remember, the code review isn't, making somebody do it the same way you did it. It's you being honest about, okay, well, what is actually better? What is more clear, right? And so they may do it in ways that you're like, oh wow, that's even better in a way. I should have done it that way. Like, great, leave that alone. You don't need to make them change. And so first you can do it on the homework assignment where, like I said, you've already done it, so you should have some of what the problem is doing, so you are more confident to talk about it. Then, right before the project's due, your team is going to code review another project's team, a code. So now a code base is not your code. So going into a foreign code base, what can you learn? What can you help them out with? Yes, TBD. But as I said, it's one that's not been due yet, so I guess not five. Yeah, exactly. So people in the audience that correctly surmise it's probably not going to be one or two. Yes, Redux. Okay, Redux is the Rust-based microkernel that had all the flashy code I saw the other day, right? But yeah, no, testing is cool. CI is cool. Code review is cool. Like I said, remember the very first thing today's lecture. If I don't know if it's like a hotkey to go all the way back to the beginning. Um, but if we zoom back to the beginning, correct. That's what I most care about, right? If I'm gonna use someone else's code, it freaking needs to work. I want it to work. And thus, if I make code I want other people to use, I care that it works, right? So these are the things to emphasize. Um, cool. Okay. What did you actually check in the code review? I'll be writing this up for the course. That's why I have not posted time because I'm still writing the instructions up. Everyone has their own checklist. They say some organizations even have, make sure these things are there. But what are things to look for? Even though the code probably has already passed your test and your CI, there may be situations where a veteran human may be able to recognize potential correctness issues even the test did not cover, right? Like you made a certain change, you saw the conversation on the review I showed a minute ago about something being public or not public, so you see how that kind of comes up. And so, yeah, there are going to be some things, even though it passes test, potential correctness implications. A lot of people fixate on readability and style. I think readability is really important. Style, hopefully, you can offload some of that to some sort of automated tool. For example, with Scala, there's something called Scala style, which has, you can give it a list of, formatting rules and it'll make sure your code complies to that, or even auto format your code according to that. If you use a IDE such as IntelliJ, under the hood it's using Scala style. Um, and yes, you really can just give an entire file IntelliJ and say, reformat this and it'll reformat it. So like the literal text formatting stuff hopefully is not an issue. Um, that can be hopefully easy. But beyond readability is also things like how is code structured? How do you choose to organize your classes and functions? How do you name things? Is there certain conventions the organization follows? Um, One thing that I think is kind of interesting opinion is you want to have it such that the code and the code base is consistent across the entire code. This improves readability. So, one function in one file is written the same coding style as another function in another style. So if you have consistent formatting throughout the entire project, consistent coding style, really increases readability. You don't want to come to a file and without even looking at the Git history, know, oh yeah, so-and-so wrote this code. I can tell from their style. It's different from this other file, which is very different. That's not what you want, right? You want to have a consistent style. Looking at the code by itself, you shouldn't be able to tell who wrote it. You need to be able to use git flame to figure it out, right? So if you can tell someone's code without git flame, probably should encourage a more consistent coding style. And this is a common point of conversation, right? Within a organization, there is often discussion about what should the coding style be. And guess what? If you go to our homepage, under reference, I have links to Scala style guides, um, even the Chisel Fertile Developer style guide. They have certain thoughts about how code should be laid out. Or even for Chisel, there's actually a Chisel style guide that was written a couple years ago, right? And so, yeah, people have opinions on this stuff, and I'm less of the opinion of having a really strong opinion, other than just it should be consistent within a code base. Within a certain repo, whatever the repo agrees upon as their style, that needs to be your style. Cool. Questions and comments on talking about the remote review things to look at. Completeness, yes, so you saw in that prior checklist we saw in the real case. Tests, documentation, other things. Sometimes someone has a pull request that adds functionality to your project. They've checked all these boxes, it's correct. It's very nice code. It's well documented. It's well tested. It includes tests, but it perhaps pulls your project direction you don't want to do, right? Or there could be cases where you imagine for software things like a legal liability. It's like, oh man, you're gonna put this in the internet, that could make us vulnerable. But even in hardware, it's like, ooh, do we want to be, in the business of doing this? Sometimes there's some things you have to pause and say, you know what, this should be maybe a big conversation, not just a single one-off code push. Yes. Oh, good question. So since we use Scala's imperative and functional programming test styles, does that hinder readability? Um, I would say some. I don't think purely functional or purely imperative is the most readable. I feel like functional programming used judiciously is still quite readable. We saw some examples in this course where perhaps having, one level functional programming, collectives, having like a single map is fine. Having a map that goes into a map that goes into a reduce, although technically possible, maybe not as easy to read. Yeah, I don't see an issue mixing, a modest amount of functional programming with a modest amount of imperative code. Like the two of them can kind of coexist. But if you have like a really weird mix, for example, let's say someone has a map call and the map call is like literally using vars to like mutate things between different elements. Code review should be like, no, no, no. This works for now, but I don't trust this. Please don't do this, right? That's what code review is for. Cool. Other questions? Cool. Okay. Documentation. Hopefully I'm getting you excited about it. If nothing else, for this course, right, I've covered things best I can during lecture, but I'm sure you've all had questions beyond what we covered here, and you've probably perused the Chisel documentation, and hopefully you found it useful. And so, yeah, documentation is really important. And it's not just about, helping people have when they have questions, right? Something as simple as is often overlooked by a lot of small projects, summarize what the project does. I can't too often I go to GitHub and come across the repo, and it's like, oh, let's pick some random name, like foobar. Okay, this is the foobar repo. The time description in the top right corner on GitHub, it says, this is the repo for the foobar project. I'm like, what the heck does foobar do? And then you go to README, and it's like, this is the repo for the foobar project. Here's our code committing rules. And it's like, but what does foobar do, right? Like, it should be really clear. Just what in the heck is this thing, right? So that's a really low bar to clear. Like 2 sentences, what does your thing do? You're surprised when repos did not pass this test, right? So that's why it's first on my list. Number one, someone comes across your code, tell them what the heck it does at a high level. Then sure, more documentation, things like instructions how to use it. Perhaps even details on the internal structure and functionality, if you have parameters, how to use that, command line options, APIs, etc. So what's interesting is when you have a project and you don't have documentation, who's the most harm? Well, sometimes people are developing code for their own uses. And so as a result, they wrote the code. So perhaps they don't see the harm. And depending on the case, I want to emphasize that that's not okay, right? Because without documentation, it's really hard for people who are not you to get into your code. You're like, oh, want to know how to use it? Just read the code. Like that's not helpful to a lot of people, right? If someone else likes your project and wants to contribute, documentation helps them on-ramp, right? So good documentation is really important in order to get more users and contributors, but also it helps the creator itself. Number one, if you're doing a lot of stuff as a creator, you're probably going to forget things. So writing it down helps, but also forcing you to write down your documentation helps you think about what is actually being done, how to explain it. And perhaps in your documentation, you may find something's really hard to explain. If something's really hard to explain, that may mean you should rethink your API and your interface, right? It may mean this is something you've not thought about the abstractions well, and you should go back and think about it. Cool. Other questions, comments? Yes. It definitely helps you. I said like the moment you wrote the code, you know exactly what it does. But from then on, you're only going to forget about your code. You're not going to learn more about your code over time, especially if you're not touching it, right? And so you might as well take advantage of your maximum knowledge of the code and write down documentation right away. So, what can you do for documentation? For this course, we have not as high of a bar, but come on, a README for your projects. Put a README in there, right? Bare minimum, right? Why README is great? Well, going back to our favorite Git repo, all this content down here, that's not a README. GitHub puts the README right there, on the web page. It renders it because it's in Markdown. But Markdown aside, it's right there when you see it right away. Even if you have this repo cloned and you can go digging around in a directory, the README is usually where people look first. So README is the first place to look. It turns out for some projects, especially their small ones, a good README is all you need, right? It's a single file, easy to maintain. You saw on GitHub, if it's written in Markdown, it'll render to Markdown, so it's a little bit prettier. But yeah, a README is kind of a good gateway. Now to go one step past that, you've seen ScalaDoc, which we have seen for Chisel, right? This is ScalaDoc, rendered stuff. It's pretty nice. How does this actually get created? Well, within the code, right, you add comments according to certain formatting rules, and that turns into the ScalaDoc. So that's pretty cool. So ScalaDoc, you might consider for your project. It's not too hard to get set up. And so a lot of IDEs even understand it, so you can get assistance in writing the comments in the correct format for the ScalaDoc. And actually, even some IDEs will render the ScalaDoc correctly in line, so it looks like it's actual HTML or whatever. It's pretty nice. One advantage from the ScalaDoc is that the documentation's next to the code. People often get worried about documentation, like, oh yeah, I'm worried, if I have documentation that it's going to come out of sync. It's always out of sync. And it's like, well, let's pause for a second about that mentality. If code documentation get out of sync, let's assume at one point they were in sync. And then at some point, someone changed the code without changing the documentation, right? Let's not lose track of what happened here, right? And so going back to the code reviews and approval process, right? If someone's changing functionality that impacts documentation, change documentation must be expected to be part of that change. Yes? Yeah, I would say the exact same argument applies to comments. People say don't write lots of comments because they'll become out of date. And the answer is if you keep them consistent, right? And so part of motivation of having things like ScalaDoc or JavaDoc, where it sends it from, is keeping the documentation and closer to each other hopefully makes it easier to keep the two in sync, right? But it also said, even if they're not next to each other, have pressure on the code review process to make sure to keep them in sync. That should be one of the checkboxes in your code review checklist, right? Um, Now, if you have really heavyweight desires for your project, actually write full-on static site. So actually, like, write proper documentation, which we've also seen for Chisel, right? So you're seeing these, nice descriptions that have, long stuff. The particular engines they use in Chisel, it's actually pretty cool. These code snippets aren't just rendered nicely. They actually are run through CI. So that way the code examples in documentation are also actually tested. So like I said, that's a good thing to have. And yeah, if you were to host documentation, this place called Read to Docs is quite nice to host a lot of stuff. A lot of things are hosted here. If you're actually writing a web page like this, looking at the actual code, you can see here it has, the Scala snippets, right? And yeah, it's, in this case, it's markdown based. Not too hard to write. So please, 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 please do that. What are my advice for writing documentation? Like I said, the thing that's always overlooked, and I'm going to keep emphasizing, include the high-level summary. Why are you doing this, right? People that are working on something all the time, all day, they're thinking about details all the time. Someone else that's not you is not thinking about those details. You got to orient them with a high-level advice. The same is true for giving a talk. Same is true for writing a paper. Understand your audience is not in your head. You need to give them that high-level orienting detail to kind of get them on track, right? Emphasize the purpose rather than how it works. So sometimes you're starting someone's documentation and it's like, oh, we have class A that does this. We have class A and class B, and then class D talks to class D. And it's like, I'm sitting here going like, why do all these things exist? Like, what are they for? So I find if you focus on the purpose rather than implementation under the hood, that's often more helpful to kind of orient people. And emphasize not so much how it works internally or a lot of abstractions, but actually just how to use it, right? How should you actually be interfacing with something like that? And before I forget, I'm going to fix this typo that I saw right now. Live documentation fixing right there. Okay, so as I said before, if you find something really hard to explain, that's probably a sign that the design itself is perhaps not well conceptualized. Same as super testing. If there's some feature or something that's really hard to test, you may want to rethink your abstractions in your class organization, which is fine. This happens, right? Like I said, you never get it right the first time. You're going to revise, restructure, but you're going to learn it and figure out things along the way. Cool. Okay. So then the third and final, or fourth, I believe, the open source pitch, right? So why should you open source your work? Well, believe it or not, by giving it away, you actually get something in return sometimes. First off, a lot of you are, grad students or undergrads. And so if you're, as researchers, right, you're trying to create new knowledge. You should be trying to help the world, right? So if you can, give it away, right? Surprisingly, people find a lot of times companies are okay if things be open source. And they may be surprised that, wait, they're paying me to write this code and they're okay with me releasing it? Depending on the conditions you're working, a lot of companies are enlightened enough to recognize some code, the code is not the strategic advantage of the company. For example, a company like Meta, who runs Facebook, is actually often quite liberal with open source, right? And the reason why is they know that their secret sauce isn't their code. Their secret sauce is literally your personal data, right? So as long as your personal data is not being leaked online, they're fine, right? So that's why they're very fine about open sourcing code, open sourcing hardware, etc. So what happens when you put open source code? Well, sometimes the community actually can recognize things and improve your code. Sometimes they'll find bugs, give you performance tweaks, that kind of stuff. I actually pushed some code out multiple times in my career, and I'm surprised where like a year or two later, somebody finds a really obscure bug I never would have found. It's like, wow, I'm really grateful they found that because I never would have found it and I would have had that bug. So yes, it can really help. Also, as many of you trying to build your careers, both in industry and academia, having a big open source profile can help. A lot of students have this mentality of, oh, my GitHub is my resume. Make sure what's on your GitHub is actually reflects your work. I think a lot of times students feel pressure to have a good GitHub repo, get a good GitHub profile, and just take all their course homework assignments and put them on GitHub. That impresses absolutely zero recruiters, right? Any recruiter worth their salt, like, this is clearly a course assignment. I've even seen students for grad school admissions also take what's course assignments, act like it's like not a course assignment, and it's just a project building their own. It's like, no, that's a course assignment. I can see like the template code from the professor. So, but even still, if you are doing open source work, it can help, right? It can really help, especially if you make something that's adopted or you contribute to things. That's really good. So do it. And then, if I'm not convinced, you have to use first three reasons to open source your code. Number four is why not? Like, what are you planning on doing? Why is it important to keep it secret? Especially in this course, where we're building so much open source stuff. That's why open source so much of this course content. All the tools using this course are basically open source, right? So why not, give back? And then, yes, there's this detail of is there a pattern or business reason you're infringing or harming, but the vast majority of the time there is not. So you should release it. I'm going to talk about licenses in a second, but any questions first? Okay, so what do you need to have open source? Well, people will say, you know what, I spent all this time making a repo, and I push it on GitHub, and then crickets, and then like 10 years later, there's like four stars or something like that. Like, what happened? Well, hopefully you have a reason why you're building the project more than just trying to get fame. But if look at open source projects to take off and get a lot of contributors and get a community built around them, what are some key features of them? Number one, does something useful, right? You laugh, I'm dead serious, right? Like, people are going to find it because they care about functionality, right? And so that's a really important thing that we're often overlooked. A lot of times these really esoteric repos, the problem they're solving is so rare that for most people it's not useful. Additionally, as I said, is it correct? And it's not just a matter of it actually being correct, it's a matter of convincing people it's correct, which is why the tests and the CI come in to help prove that. Documentation can help, right? People can actually approach this and understand what's going on there. Sometimes a little publicity helps, a little promo on social media or something, right? And then finally, you need an open source license. Okay, so we'll start more with licensing. So believe it or not, whenever you write code, it's your code. So you have the copyright on it, or you could claim the copyright on it. And guess what? If you just chuck it online, people could see it, but technically they actually don't have permission to use it. So the license file is you actually granting them permission to use your code under certain conditions. So without the license file, they basically have permission to do nothing. So people are like, oh, I keep this repo private because I haven't, figured out what license I want to use yet. It's like, actually, you make it public early, and without a license, technically they have no permission to do anything, what the actual status is. So if you have an open source license, that is you giving permission to have this code used in certain ways. And so without license, it's not really open source. It's there, but it can't really use it. So the whole point of license is specifying, and especially being very explicit and very clear about what is allowed and what is not allowed. And so that's a whole family of choices, but that's kind of initial legal setup. So what are the main parts of these licenses? Most open source licenses allow you to use something and even modify something, but that's where the details start diverging, right? For example, when you use it, can you use it for anything? And anything, usually personal use is almost always allowed. Educational research use is very typically allowed. But like, what about commercial purposes? That's the one where licenses start to differ, right? Meanwhile, if you change it, are you required to distribute those changes? Can you include this project in a bigger project, right? So there's a whole bunch of, stuff. This is way beyond the scope of this course. If you want to get detail about the exact legal nuances of this, people spend their entire careers being, open source lawyers, expert in this stuff, but just have a picture of being aware of some of the, the trade-offs and controversies. Additionally, for license, are you allowed to use any trademarks or branding associated with that? For example, if I download code produced by a UC campus, has the University of California, can I use the University of California to endorse my project that's using their code? No, you cannot usually. That's the kind of stuff that comes up. And then this is a really subtle one that's often overlooked. Okay, you wrote up code, you put an open source license on it that gives people permission to use this code, let's say for a commercial purposes, they can modify it, whatever. Now, or final to that code includes functionalities that are patented. How does that work? Well, technically, depending on the patents and nature of how someone uses this code, they may be using your code legally in the sense of what the code allows it to be used for. However, by using that code, which implements and embodies a patent, they may be infringing on the patent. This is a really important issue because, you may have made code open source, but without the patent grant, it may be really frightening for organization to use because they don't know there's not a lurking patent in there for them. This is when it comes to a lot of companies adopting open source code bases, there's often a concern about their point of view of risk. And when they say risk, there's also security risk. We're talking more about what is the likelihood this company gets sued and the suit succeeds, right? And so there's cases of breaching open source license contracts, but usually license specifies what is and is not allowed. So usually it's pretty clear. But then there's questions about patents, right? And so some licenses have what's called a patent grant, meaning someone's allowed to use patents the organization holds as long as using it in the context of this code base, right? And for example, here we are at UC Santa Cruz. This actually is quite relevant for us. So we are a member of the University of California system, which is the largest non-federal patent holder in the US, right? So yeah, a patent grant from UC carries some weight. Cool. What are some licenses? I'm not going to get into tons of detail, but basically the most common, very liberal, permissive ones are things like either BSD or MIT. So BSD stands for Berkeley Standard Distribution. So it actually was associated with one of the early versions of Unix that was commonly shared. So as you can tell, both these licenses came from universities, right? So because of that, they really kind of tend to be, very permissive. You can do a lot of things with them. And so typically with these ones, yes, you can distribute it. You can use it for commercial purposes. You also can modify it without redistributing the changes. So it's basically, pretty unrestricted. And most of the licensing is kind of restricting your ability to both do branding and that kind of stuff. GPL has been around for a while. There's a few different versions of GPL. The newest version of GPL, v3, is commonly used, but it has a lot more restrictions. So as a result, some companies have policies in place where they don't allow their company to use GPL v3 code, right? And so in the case of GPL v3, the key thing is if you modify, there's some requirements you have to distribute the modifications, and that's a real deal breaker for a lot of organizations. Additionally, when you include it in certain code bases, there's also some implications how that needs to be distributed when it's included in other code bases. And so for those reasons, it's actually kind of, a little scary for some folks. Apache v2 is getting a lot of adoption recently. And the reason why is permissive like the first two, the BSD and MIT, but it includes that patent grant, right? So for example, here's the University of UC Santa Cruz, right? You release the code BSD. That's really permissive. That's pretty low risk for most companies. But if they're being paranoid, they say, no, wait a second. UC's got a lot of patents. How to make sure UC doesn't sue me? Well, if you manage to use your code as Apache v2, you've also given a patent grant, meaning any patents included in that code, if their code uses those patents in a way that's responsive to that repo, you're not going to be suable for that particular liability. So that's very popular. And then on the extremely liberal side, there's some kind of fun license things. There's something like, unlicensed, which basically knows this, I basically reserve nothing, or even one that is amusingly called, the WTF public license, do whatever you want with this basically this kind of notion. Very, very permissive. Any other questions or comments? Yes. Oh, there's dozens of licenses. Yeah. This is me giving you a flavor of the most popular ones. Yeah. Sure. But I mean, it's always changing. I said licenses every 5, 10 years, and make a new one to try and fix that. And just like any other standard, oh, there's N standards. We should make one standard to fix them all. Now it's N+1 standards. So I think it's true for licenses. Um, Here's something that's perhaps under discussed. Where do you put your license file? Usually you have a license file in the root directory, and that's great. That way, easy for people to find. For example, hey, here in the Chisel repo, there's a license file. And guess what? Because it's a well-known standard license, GitHub can even recognize it. Oh yeah, this is Apache v2 because it, understands it, and even reminds you, what are some of the details. I said, remember the whole point of Apache was you're going to use the patents, right? So that's awesome. Okay. Now there's a recent push for this. This is something that is kind of cool. In a large code base, you may have multiple organizations contributing to code, and it kind of becomes unclear which files fall under which license. Some large courses have multiple license files. In those kind of scenarios, this particular standard is actually trying to make it easier for tools to read code. So believe it or not, there actually are not just people, but codes that exist to, given a large project, which includes a lot of other projects, to go through all that and figure out which licenses you're using, which licenses you're exposed to. And so, for example, if we go back to like the code that was used to generate, oops, I guess I already closed it, but I can pull it up in a second. Actually, we can get it from here. Um, so up here at the top of the file, this random comment is actually not a random comment. This is actually that particular protocol to tell, hey, this is Apache v2. Cool. That's where you put it. And when it comes to your project, you want to make people contribute to it. Like I said, make it interesting and useful. Testing helps people contribute. That way to make sure they know they didn't break it and you know they didn't break it. Document it. Also, when you have a project and people open pull requests, respond to the pull requests. If you leave it open for like 2 years and someone sees a bunch of unresponded pull requests, it's not very inviting. Be positive, be polite, be encouraging, actually respond to things. You also can have things like suggested projects, right? Like, yo, hey, you want to contribute? Here's some things you can try doing. So I've covered a lot of things. Hopefully you'll try out for your project. If not, in your future careers, things like CI, code reviews, documentation, releasing, etc. Cool. This last slide is just links. Great. Any last questions? Okay, that's